This is section 5.1, Systems of Linear Equations in Two Variables. In chapter 5, we're going to be talking about systems of equations a whole lot. We are going to be learning several different methods for solving these things. But first, we have to know what a system is, okay? What a system is going to be a set of equations. Right here, we have two variables, and in general, to solve a system of equations, you need to have the same number of equations as you do variables. So right here, I have x and y, two variables, so I need two equations in order to be able to solve it. In a later section, we will have x, y, and z, so we will need three equations in order to solve it. Generally speaking, if you don't have the number of variables and the number of equations matching, then it's usually not going to be solvable. And if it is solvable, it's because you have some sort of special case going on. Okay, so what we have here is we have a system of linear equations. Linear because I have no squares or anything else on here. And what we're given is an ordered pair, and we're asked whether the ordered pair is a solution to the system. Now, why an ordered pair? Because we're not going to solve these this way, but one way of solving a system is to graph both lines. So if I graph this line, and then I graph this line, and I'm just, of course, sketching the possibilities, the answer to the system of equations is the point where they cross, which would be an ordered pair. So we use the language of graphing a whole lot. It is not the most practical way to get it solved, and so that's the reason we're not focusing on it too much. Now, right here, if we are going to check this, that means if I plug in -3 for x and 5 for y, it should check out. And it has to check in both equations. Now, this ordered pair might work here, but not here, or vice versa. It might not work in either one, and it might work in both of them. But if it doesn't work in any one of them, then the answer is no, it is not a solution. So let's just take this and substitute it into this first equation. That will be 9 times -3 plus 7 times 5 is equal to 8. And that is -27 plus 35 equal to 8. And 35 minus 27 is 8. So it checks in the first equation. Now let's go ahead and do this here. This would be 8 times -3 minus 9 times +5, and that would equal -69. Multiplication would be -24 minus 45 equal to -69. -24 minus 45 is -69. So yes, it is a solution. Okay, so let's do the same thing with this next one. I again have two equations, and I'm given a potential solution of 8, 5. I'm going to take this 8, plug it in here, the 5, plug it in here. 5 times 8 minus 4 times 5 should equal 20. This gives me 40 minus 20 equal to 20. And 20 does equal 20. So 8, 5 is a solution to the first equation. Now let's do the same thing here with this one. We don't have the x and y in the same order here, so be careful that you're actually plugging in the correct thing. So 3 times y would be 3 times 5 equal to 2 times 8 plus 1. This is 15 equal to 16 plus 1. 15 does not equal 17. So the answer is no. It is not a solution. Okay. So it didn't work in one of them, so it's not a solution. If I had, for whatever reason, chosen to check in this second equation first, as soon as I got a no, there would have been no reason for me to check the second, because they both have to be working in order for it to be yes. So if any one of them doesn't work, it's not a solution, you can stop. Okay, so now let's start talking about how to solve these. The first method we're going to discuss is the substitution method. Now, to use the substitution method, what you want to do is you want to take one of your two equations, it does not matter which one, and solve it for a variable, and it does not matter which one. So if I wanted to, I could rearrange this so I had y equal to 6 minus x. Or I could rearrange it so I had x equals 6 minus y. But this second equation right here is already solved for y. So it's gifted to you. You've got part of it done, you may as well use it. So what do? As soon as you have one of your two equations solved for a variable, what you're going to do is going to take the other side and replace it for that variable, whatever it is, inside the other equation. So what I have is x plus, instead of y, we know that y is the same thing as 2x, so x plus 2x is equal to 6. Now what this should do for us is we should now have an equation that has only one variable in it, and we know how to solve those. Combine like terms here. I have 3x is equal to 6. Divide both sides by a 3. And you get x is equal to 2. Now, a lot of people stop here, but you are not done. Your answer is going to be an ordered pair. And we need both the x part and the y part. What we have found so far is the x part. Now, how do we find the other part? We do what we call back substitution. Which means taking the part that you now know, and you're going to come back here to your original equations and plug in this value. It should not matter whether I plug it in up here or down here, I should get the same y value. And if I don't, then I've made a mistake. So just pick the one that looks easier to you, and it looks easier to me to plug it into this second equation. So I have y is equal to 2 times x, but x is 2. So that would be 4. So my answer should be the point 2, 4. To check, you would plug them in. This would be 2 plus 4 is 6, which is correct. And y is 2 times 2. So 4 is 2 times 2, so it does check out. Okay. So let's solve this system using substitution again. I look at this whole thing and I need to solve one of my two equations for one of my two variables. And since this is a y with either a 1 or a -1 coefficient, this is probably going to be the easiest thing to solve, and I'll solve it for y. If this would work on any of the others, we would just end up with fractions in it because we would have to divide by the coefficient. If I take this one and I move the y over to this side, then I end up with y is equal to 2x, which seems awfully familiar. Okay, so now I'm going to take this 2x, and you want to take all of this and plug it in. Since this is the equation we solved for y, we have to make sure that you plug it in into the other equation, because if you plug it in here, you are essentially just checking that you solved y correctly. You want to plug it in up here. So what I have is 4x plus 3 times y, but y is 2x, equal to 0. So this is 4x plus 6x is equal to 0. Combine like terms to get 10x equal to 0. Divide both sides by 10, and you get 0. 0 can be in the numerator when you divide, it just can't be in the bottom. So x equals 0 is, I have the x coordinate of my ordered pair. Now we need to back substitute to find y. And it doesn't matter which one you go into. And since my y value here, again, since it only has a coefficient of 1, that's probably going to be easiest. So I take that and plug that in. I will have 2 times 0 minus y is equal to 0, which is negative y equal to 0. And then technically what you're doing here is you're multiplying both sides by negative 1, which gives you y equal to 0. So 0, 0. If I were to plot these two lines on the same coordinate system, the point where they would cross is exactly the origin. And that would be our only solution.